and then we'll look at the different functions. Okay, so I'm going to write a function. Can anyone give us a function? Shubham, you want to give us a function? Let's make it quadratic.
Any numbers?
No, I want a function that is quadratic. Okay, Haber, you want to give us a function that is quadratic?
Yeah, would like x squared.
Great job. Plus?
X plus 2.
Great job. Excellent. Thank you very much. It is a quadratic function. However, this is what I see. Which means, now if you ask me to evaluate when this function is -3, no problem. If somebody else is asking me to find when x is 0, no problem. If somebody's asking me to find when x is x plus h, no problem. Because I understood the pattern. The pattern that Haber came up with, he said this: whatever squared plus whatever plus 2. Use the pattern and evaluate. So I'll start, let's say, with f of 0. I have 0 squared plus 0 plus 2. Done. Okay, now I want -3. Done. Why it's no difficulty? Because I understood the pattern. The pattern he created was blah blah squared plus blah blah plus 2. That's what I'm doing with all these problems, in all these evaluations. So -3 squared is 9 minus 3 plus 2, 11, or if you want -1 plus 9, so it's 8. Why? Because I have the pattern down. Something squared plus something plus 2. But of course, what I'm interested in at this point is finding f of x plus h. Anyone would like to give it a shot? Take it slowly and tell us first, the first step, what we need to do.
Parentheses.
Yes?
And then x plus h.
Great job. And squared. Great job.
Plus.
Yes?
Parentheses, x plus h. And then plus x of h. Or x plus h.
So one more time. We got down the pattern. The pattern is blah squared plus blah plus 2.
Oh, there are 2.
Exactly. Okay, Brianna, would you like to tell us how to square x plus h squared?
Would it be x squared plus 2xh plus h squared?
Here's my answer. Great job. Thank you. Plus x plus h plus 2. It's done. We cannot simplify this any longer. Okay, so we know how to evaluate functions. Now we want to find and fully simplify the difference quotient for different functions. And let's start with the one that we just got here. I'm going to call it Haber function. Okay, so we want to find the difference quotient for, which we already know this has to be carved in memory moving forward. So please remember this. It will save us a lot of time throughout the semester. Okay, so obviously, let's identify a few things here. The difference quotient, if you look at it, if you didn't know anything about it, I'm sure you would have said, oh, I see three pieces. I see this piece, f of x plus h. I see this piece, which is f of x. And I see this piece, which is h. So obviously, I see three pieces. Do I have this one? It's just plain h. Yeah, there is nothing special about it. Do I have this one? Yes, I do. It's x squared plus x plus 2. Do I have this third piece, the biggest one? Yes. We just simplify it. It's right here. This whole thing is x squared plus 2xh plus h squared plus h plus x plus h plus 2. Okay, so what's the big deal? Nothing. I will continue. I will put all the pieces together. I will replace f of x plus h with what we just determined. X squared plus 2xh plus h squared plus x plus h plus 2. Now I have to be very careful because I have to distribute -1 to these three terms. Gabby, would you like to give us?
I'm sorry, can you repeat that?
Yes. So now we are here. We want to put this with minus in front. No parentheses. We want to simplify it.
How would you just like factor it? Is that what you're asking?
So I have minus this quantity. How do I write that?
Would you just put it there? I don't know.
Can you distribute -1 to these three terms for us?
Oh yeah, so just negative x squared minus x minus 2.
Brilliant. Okay, now, before we continue, two things must happen here. Number one, all terms without h must simplify in the numerator. Let's see if that happens. If this doesn't happen, I made a terrible mistake somewhere. So do all terms without h in the numerator, specifically in the numerator. Do they all go away?
Yes. Yeah.
Because x squared with negative x squared, positive x with negative x, and positive 2 with negative 2. Great. The second mandatory step is h from, I don't know if you can see, I'm trying to look and see if you can follow here. H from the denominator this time must simplify with an h from the numerator. So let's see. So I will continue. I'll put a square here, so I don't have to write it again. And here it is, my square. The numerator now is 2xh plus h squared and plus h divided by h. Does the numerator have a common factor?
Yeah, it's H.
Very good.
And then that cancels out. That's
Good.
fine.
In a moment it will. Perfect. Yes, that's the step 2. H from the denominator must go away. Okay, perfect. Can Savannah give us the 3 terms? 3 terms in the numerator, please. 3 terms. I'm ready.
Would it be 2x plus h?
3 terms. I have 1, 2, 3. 3 terms. I have to have 3 terms left.
Oh, would it be plus h again?
It'd be plus 1.
Very good. H times 2x, 2xh. H times h, h squared. H times 1, h. Agreed? So then the final simplified form, again, can anyone? Rita, would you like to give us?
2x plus h plus 1.
Good. What does this represent?
The difference quotient.
Excellent. This is the difference quotient, and it is almost the instantaneous rate of change of f of x. Almost. You will see what happens that we get when we get the exact. Okay. Finally, where is my, okay. This is exactly the same thing for a rational function. And the rational function is f of x, in that problem, 1 over x squared. Okay. So let's start by determining the difference quotient and simplifying it. What do you think? Can anyone give us the difference quotient? Michelle.
Plugging in this equation, so
Let's just write the difference quotient first, and then we'll continue here.
okay, so f of 1 over x squared.
F of x plus h minus f of x divided by h.
Oh, okay.
That's
yeah.
the definition. And now I'm ready. Yes.
Okay. F of 1 over x squared plus h minus 1 over x squared over h. No.
Okay, so let's talk about it. So obviously it's not clear. So coming back to our function. Okay. So how did we determine f of x plus h for this function? We looked at the pattern. The pattern says blah squared plus blah plus 2. So now the pattern here says 1
yeah.
over blah squared.
Mm-hmm.
So let's try again.
1 over 1 over x squared plus xh.
Very good point.
2xh.
Never expand the factors in the denominator. I wasn't trying to be tricky. There is no denominator here. We have no choice but expand everything when we plug in x plus h. But here, this is the denominator. We never expand the factors in the denominator.
Okay, so 1 over x plus h squared
Great job. Awesome. And then?
minus 1 over x squared.
Excellent. Dividing by h. Great job. This is all we have to write initially. Next step. Now we have to find the least common denominator in the numerator. Can anyone give us the least common denominator in the numerator?
Which numerator?
Very good. This is called numerator. Where I have a subtraction of two fractions. That's why I need the least common denominator. And this is the denominator. See, the fraction line, it's a very good question. The fraction line indicates which one is the numerator and which one is the denominator. We're not talking about pieces. This is the fraction line, it's a difference quotient. This is the numerator and this is the denominator. And it continues. This is the numerator, this is the denominator. So we are now subtracting these two fractions. I need a least common denominator in order to continue.
Would it be x squared it looks in parentheses x plus h squared?
Well done. Well done. Somebody taught you well. It was me. She was my student. So I had to praise myself for a second. Okay. Thank you, Zainab. Very good. Okay, so now, do we all understand why the least common denominator is that?
I do, yeah.
Any questions?
I do have one. Wouldn't there be a 1 on top of that?
Very good question. So let's talk about that. So if I have 1 divided by 2 minus 1 divided by 3, the least common denominator is never 2 plus 3, please. Is always the product if they don't have anything in common. So it's 6. Now the question is, do I write 1 minus 1? The answer is no. So when I write the least common denominator to be 6, I'm automatically asking myself 2 times what is 6? So I multiplied by 3, which means I have to multiply the numerator by 3. 3 was multiplied by 2 to get 6. Automatically, mandatory, I have to multiply the numerator by the same quantity. 3 times 1 minus 2 times 1, and this is how I get 1 over 6. Otherwise, it will be 0. In the same way, I continue here. It's the same principle. Of course, this looks more difficult because it has x and h in it, but it's the same principle. The denominator is x squared times x plus h squared. The initial denominator was x plus h squared. It was multiplied by x squared. Mandatory, I have to multiply the numerator by
X squared.
Absolutely. The initial denominator had x squared. I multiplied it by this quantity. So the numerator has to be multiplied by, automatically, mandatory for sure, by
X plus h squared.
That's it. Now let's stop for a moment. Did everyone